Welcome students. Now we will discuss with the engineering physics syllabus module number 5 material science. In previous video we have discussed about the conductors, dielectrics and semiconductors. Now we will discuss with the semiconductors only. Now classification of solid based on the band theory. Solids may be classified in terms of their conductivity as conductors, insulators and semiconductors. Now we are discussing about with the semiconductors. What is the semiconductors? Semiconductors are those materials whose conductivity lies between conductors and insulators. Whose conductivity lies between conductors and insulators. The best examples we have considered here for the semiconductors is germanium and silicon. Germanium and silicon are the semiconducting materials. It is a partially a conductor and partially an insulator. Here the valence band is almost filled and the conduction band is empty or it may be weighted. The energy gap for the semiconductors is nearly 1 electron volt. What is the 1 electron volt value is 1.608 into 10 to the power minus 19 joules. Hence, at low temperature, semiconductor behaves as insulator, and as temperature increases, the conductivity also increases. When the temperature is increases, the conductivity also increases. Here, the conductivity of solids can be explained on the basis of the band theory. There are three bands: valence band, conduction band, and forbidden energy gap. Now, first we will discuss with the valence band. What is a valence band? The range of energy possessed by valence electrons is known as valence band. The range of energy possessed by valence electrons is known as valence band. In the valence band, the electrons in the outermost orbit of an atom is known as a valence electrons. The valence electrons have the highest energy. Valence, it may be completely filled or it may be partially filled. Second one is the conduction band. The range of energy possessed by conduction electron is known as conduction band. The range of energy possessed by conduction electrons is known as a conduction band. Now third one is a forbidden energy gap. What is a forbidden energy gap? The separation between conduction band and valence band on the energy level diagram is known as forbidden energy gap. The energy gap is nearly 1 electron volt. Already I have discussed. Now, what are the types of semiconductors? There are two types of semiconductors. First one is pure semiconductor or impure semiconductor. Or pure semiconductor we are also called as a intrinsic semiconductor. See here, pure semiconductor or intrinsic semiconductor. Second one is impure semiconductor or extrinsic semiconductor. Now, what is a pure semiconductor or intrinsic semiconductor? Means a semiconductor in its pure form or a semiconductor in which does not have any external impurities is known as a intrinsic semiconductor. Now, expression for electron concentration. Expression for electron concentration. E is the electron and N is the electron concentration. Here directly we have considered the equation. Ne equals 4 root 2 upon h cube pi me star kt to the power 3 by 2 e power ef minus eg by kt. Here m star is the effective mass of an electron and k is the Boltzmann's constant and T is the absolute temperature. Ef is the Fermi energy and H is the energy gap and H is the Planck's constant. Similarly, we will write the expression for Hol's concentration. See here, Hol's means H we will written, concentration means N. NH equals 4 root 2 upon H cube pi mH star K to the power 3 by 2 e power minus Ef by Kt. These are the expression for electron concentration and Hol's concentration. Next topic is explain Fermi level in an intrinsic semiconductor. Now, to explain the Fermi level in an intrinsic semiconductor, first we need to consider the energy graph. See here, this is a conduction band, this is a valence band. This, what we have considered the line. Okay, this line is called as a Fermi level. Or this energy gap is called as a forbidden energy gap. This gap already I told is very small. From the graph, Ag is the energy gap difference between the bottom of the conduction band, means this one, and top of the valence band. This is called as a energy gap. Now, first here at a temperature T equals 0 Kelvin, all the energy levels in the valence band is completely filled and all the energy levels in the conduction band is completely vacant or completely empty. When temperature is greater than 0 Kelvin, due to thermal energy, electrons gain energy and excite to occupy the energy levels above the valence band and leaving a vacancy. When it will leaving a vacancy, there it will be a holes can be generated. These electrons soon to the valence band which they had left vacant in the recombination. When the recombination will take place, one can say that the conduction electrons are distributed between the energy levels in the bottom part of the conduction band and top portion of the valence band. The average energy of the electrons taking part in the conduction band will be equal to half of the Eg. That is a 1/2 Eg. Here, thus the Fermi level lies in the mid portion of the energy gap for an intrinsic semiconductor. Here, EF is the Fermi energy of the Eg. That is the energy gap. Now, next topic is explain the law of mass action. What is the law of mass action? Here, the law says that for a given semiconducting material, either intrinsic or extrinsic. Here, we are discussing about only the intrinsic semiconductor. The product of the point charges or charge carrier concentration remains constant at any given temperature, even when the doping is varied. What is the doping? Adding of impurities to the pure semiconductor is called as a doping. Now, here if Ne is the electron concentration and NH is the holes concentration. Here, if Ne is the electron concentration and NH is the holes concentration, we will consider the equation for Ne and NH. Okay, this electron concentration equation and this is the holes concentration equation. The product of Ne and NH is a constant. See here, Ne and NH if you multiply, we will get 32 to the power h cube by h to the power 6 by kt to the power 3 by 2 me star ms star to the power 3 by 2 e power ag by kt. Now, if we reset all the constants, Ne into NH equals constant. This is the law of mass action. In case of intrinsic carrier charge concentration, Ne into NH equals Ni. Ni is the intrinsic carrier charge concentration. Hence, Ne into NH equals Ni. Ni into Ni will get Na square. That whole value we will get is a constant. That is a law of mass action. Next, derive the expression for Fermi energy and energy gap for an intrinsic semiconductor. For an intrinsic semiconductor, the number of holes per unit volume in the valence band is equal to the number of electrons per unit volume in the conduction band. We know that number of electrons equals number of holes. Here, we know the equations for electron concentration and holes concentration. Now, if you multiply by Me star to the power 3 by 2 e power Ef minus Ej by Kt, Ms star to the power 3 by 2 e power minus Ef by Kt. Now, here e power 2 Ef minus Ej by Kt, that is equals Mh by Me star to the power 3 by 2. If we simplify, we will get this equation. That is a natural law. We will take the both these sides. 2Ef minus Ej by Kt, 3 by 2 limit, Ms star by Me star. Now, Me equals Mh, mass of electron equal mass of holes. Now, 2Ef minus Ej by Kt equals 3 by 2 limit 1 because electrons equals to holes. Now, 2Ef minus Ej by Kt equals 0 because limit of 1 equals to 0. Hence, the entire term we will consider as a 0. Now, 2Ef minus Ej equals 0. Ef equals 1/2 Eg. Thank you.